Most of us operate on a basic assumption that our decisions are the product of logical intent. We set a goal, we make a plan, and we execute it because we are rational actors in control of our own minds. Until, of course, we are abruptly derailed. We know exactly what we need to do to hit a deadline, maintain a diet, or stay calm in a high-stakes meeting. Yet in the critical moment, we routinely do the exact opposite. We procrastinate, we indulge, we snap. Our observable behavior consistently contradicts our stated professional and personal goals. The standard cultural response to this contradiction is to treat it as a moral failing. We tell ourselves we lack discipline, grit, or willpower. We assume that if we just tried harder, we could force ourselves to behave differently. But this self-help narrative gets the mechanics of the brain completely wrong. When you lose control of your behavior, you aren't experiencing a lapse in character. You are experiencing a structural mismatch, a literal hijacking of your neural circuitry. The brain does not operate as a single, unified executive board. Instead, it functions as a collection of competing neural systems. Crucially, these systems activate at vastly different processing speeds. To actually gain control of our behavior, we have to stop trying to overpower the mind with brute force discipline. We have to treat the brain like the machine it is and learn to engineer around its mechanical flaws. This engineering approach comes from Professor Steve Peters. He is a clinical psychiatrist who has spent over 30 years working with elite performers, including Olympic athletes and world champion sports teams. When dealing with athletes operating under extreme pressure, abstract metaphors about inner strength are useless. Peters needed a highly functional, mechanical framework to explain cognitive processing in real time. The result of that clinical work is known as the Chimp Model. The model strips away the density of neurochemistry and brain imaging, translating complex neuroscience into an accessible, tripartite systems architecture. It divides the mind into 3 distinct operational units. The framework draws on decades of field testing, rigorous clinical trials, and formal academic interventions. Treating the mind as an engineering problem rather than a philosophical one turns out to be the necessary first step to unlocking sustainable, high-level performance. The first system, the chimp, represents the emotionally driven brain, reacting instantaneously. The second, the human, operates on logic at a significantly slower speed. The third is the computer, a memory bank both consult for learned behaviors and automatic scripts. The conflict arises entirely from latency. Because the chimp processes environmental data so rapidly, it reacts to stress and initiates action long before the logical human system has even fully booted up. There is a simple diagnostic test to recognize when this happens. If you catch yourself exhibiting a behavior or having a thought, and you ask yourself, "Do I want this?" and the answer is no, your chimp has successfully hijacked the system. This leads to a brutal operational reality. Because the emotional system operates on raw speed and instinct, you can never out-argue or out-muscle the chimp in real time. Willpower relies on the human system. Because willpower is a slow-activating cognitive tool, it is mechanically incapable of intercepting a fast-activating emotional impulse. If fighting the chimp is guaranteed to fail, the only viable strategy is to actively reprogram the third system, the computer. It runs 2 programs. First are autopilots, intentionally designed environmental cues and automatic protocols that bypass the emotional chimp, allowing you to execute desired behaviors without thinking. The second type are gremlins. These are the destructive, sabotaging automatic habits that you have accidentally acquired. To stabilize your behavior, gremlins must be identified and structurally scrubbed from the system. Installing an autopilot is essentially an act of proactive design. You are placing a physical or operational constraint on your environment well before a stressful event occurs, ensuring the chimp never gets triggered in the first place. Relying on environmental architecture and automatic routines requires drastically less energy than constantly trying to summon in-the-moment discipline. We can see the exact mechanics of this system working in real-world data. Michelle Simpson, an educator and researcher, conducted an academic intervention study to measure how independently accessed self-regulation support impacts behavior. She applied this model in a highly volatile clinical setting, a primary 7 classroom containing pupils who suffered from severe self-regulation deficits. The baseline behavior was highly disruptive. When these subjects faced academic stress, their emotional systems hijacked their logic. They would literally flee the room, missing vital instruction and derailing the entire class. Traditional disciplinary measures, instructing the pupils to use their willpower to sit still and focus, failed consistently. The fast-acting emotional response easily overpowered any logical instruction. Simpson abandoned the concept of willpower entirely. Instead, she used the Chimp model to engineer physical autopilots directly into the classroom environment. She implemented specific structural changes. She built a quiet, weighted den. She placed visual cues on desks to clarify expectations and offer immediate, tangible paths to follow. She also taught the students the AMP protocol. AMP is a cognitive sequence to slow, rapid emotional thinking. Accept a situation, decide how to move forward, and make a practical plan. Simpson essentially turned the physical classroom into an externalized computer system. By pre-programming the environment with physical and procedural boundaries, she ensured the subjects no longer had to rely on their inner logic to maintain control. Looking at the pre-intervention data on the left, the jagged purple line plunges to 1, documenting frequent exits. The green line marks the target score of 5, which willpower failed to maintain. However, post-intervention data on the right shows immediate stabilization above the goal line. The pupils' internal emotional impulses didn't magically disappear. They were simply intercepted. Before the urge to run could hijack their system, the new environmental autopilots captured that energy and redirected it to the quiet den. Furthermore, the study noted that when subjects were given a sense of ownership over these structural supports, their motivation and compliance skyrocketed. They engaged with the tools because they helped build them. Shifting the regulation burden from internal willpower to external systems yields these immediate, measurable improvements in performance. We place an enormous amount of professional value on grit, mental toughness, and hustle culture. Success supposedly belongs to those who simply endure friction. But trying to force compliance in the middle of a crisis is a structurally flawed strategy. You are attempting to solve a fast activation problem using a slow activation neural architecture. By the time your logical brain realizes you need to apply discipline, the latency window has already closed. The emotional system has already taken over and executed the destructive behavior. Judging yourself for this delay is exactly like getting angry at a computer for taking time to boot up. It is a strict hardware reality of the human brain, not a defect in your character. The professionals who consistently succeed in high-pressure environments do not possess a larger reservoir of willpower than those who fail. They simply rely on willpower significantly less. Sustainable behavioral control is exclusively a matter of environmental design. You have to audit your environment and actively remove the friction that wakes the emotional system. You replace that friction with predefined cues that trigger the automatic routines stored in your cognitive computer. The operating parameters of your mind are permanent. You cannot silence your emotional impulses, and you cannot accelerate your rational logic to outpace them. Your only point of absolute leverage is pre-programming your automatic responses before you ever need them. Over time, this structural programming integrates into the stabilizing architecture of your identity.